Okay, I'm going to be working with. I'm trying to learn a little bit more today about hash tables or hash maps, and I actually have some familiarity with this, but I have never actually implemented it in code, especially in JavaScript. And other languages, they already have their own baseline implementation, but I felt like I really wanted to get my hands into the weeds of like what's actually going on under the hood. So that's what I'll be doing today. I'm actually grabbing some of my information and my implementation from this video here from Boo Teaches JavaScript Hash Table. If you haven't seen it, definitely check it out. That's where I'm pulling my information from and like how he implemented it. He used like arrays to store his data. But let's go in, just make a hash table.js and look at what that looks like. All right, coolios. Okay, so I'll be making a class and hash table like that, and I will have it start out constructor with a storage as an array. Okay. Anyway, let's see what this looks like. So first, I'm going to have my constructor have a bin size as the argument here. I think I will start it off by default at 10 just in case something is added. So this dot bin size equals bin size. Okay, cool. I can also do, I kind of like, honestly, I kind of like the kind of like just doing it like this. Less elegant, I guess. It's fine. Defaults are either way in JavaScript. Anyway, so here is how it's stored. Now, how do we actually set it up? So we need some kind of hashing function. So I'm going to define that here. So this is my hash function, and it's going to take some string. I think I call it str. And to start it off, I'm going to have my like total sort of at 0, and I'm going to just take each element of the string. So the string is like maybe 5 letters long. Each character, I'm going to convert that into a number. I've actually forgotten how to do that in Java. So code add, right? So I'm going to do for let I equal 0, I less than the string dot length, or yeah, dot length, and then I plus plus. Okay. I'm sure there's probably a more efficient way, but whatever, this is going to work just fine. And here I'm going to, well, I'm going to do total plus character code at, so I need the string I dot character code at 0, or I could just do string character code at I. That should be fine. And then you add that up together, and so let me just quickly do a ht equals hash new hash table. I'm going to give it 5 just because I want to be different. And we will ht.hash bob. Okay, I'm going to console outlog this. Alright, coolios, let's run this. I think I can do that in here. Node. There, okay, oopsie daisy. So it should work now. Or not. Total is not defined. You're right, total is not defined. Let. Oh man, I gotta really get better at that. Okay, so it did not return anything because it didn't return anything. Of course, so return total for now. Return 307, perfect. And now we do our modulus, and this is a way of ensuring that we actually get everything into, we force this number to be within the array, the number of bins in the array. Because I have this bin size, I can now use that as my modulus. So it's effectively like saying, hey, divide this out and give me the remainder, and the remainder is the position in the array, in this case 2. The larger the bin size, the larger your array can be, and therefore the more bins you have. Depending on what you're storing, you kind of want to be a little bit efficient with your storage as well as the bin size. So if you have like 10 things that you're trying to store, do you need a bin that's 100 long? Probably not. Another issue that will come up is something called collisions. So right now I have the word Bob, but let's see if I have whatever. Okay. Let's see, Bob 1, Bob 2. Let's see what happens with those. So if you saw, so Bob by itself and then Bob 2 have the same indices. So that is going to be something called a collision, which is an issue you have to kind of anticipate. What we're going to be doing is implementing a array of arrays, so that when we store a value at a position, we're going to be storing an array that is the key and value. The 0th position is the key, the 1 position is the value, and if a collision happens, we're just going to add another one to that sub array. We're going to add another list to that bin, and that's what we'll be doing. So we have to anticipate that when we do the searching and inserting, we have to take that into account. But our hashing function looks like it is working as intended. So yay for that. All right, so let's go over and talk about insert. Or add, I guess. So add your key and your value. Oop. Val, okay. So if I want to add my key and value, hold on, let me do something real quick. So let's say const in I equals, and we're going to be using the hash function to do this. You hash the key, and then that gives you the indices of where you want to insert at. And we need to look to see, okay, does the bin already have a value in there? If not, then we have to kind of create it. So we need to say if this dot storage at I, and Python. I need to put parentheses too, man. Python, I'm telling you, Python is messing me up here. So if this dot storage, then you already have. That means you already have something in memory, or have something in that bin already. So we need to append to that. So I'm going to put that here. So this is like already has key value in bin. Okay. So this is just a matter of storage. We're going to append, and we're going to add our new key value here. And we're just literally just adding it, tagging it onto the growing array that is the bin, that is that bin. If it doesn't exist, no bin found, we need to create that bin. So it's going to be literally storage at I, and I made a mistake here. I need to put at I. That's where you append it to. Oh no, sorry. I'm messing this up. So storage at I equals an array, and then this dot storage. Okay, so that. Okay, I'm like 3 steps ahead in my head here. I'm not going to need this else statement because I'm just going to take into account the situation of if the bin doesn't exist, create it, and then you will always add to the that storage bin whenever you want to add about it. Unless, oh man, that's really loud. Unless the key already exists. If the key already exists, then you want to overwrite the previous key. Okay, so that's something to keep in mind. So check if key already exists too. If so, overwrite val. Okay. Okay. Wow, look at all the stuff that's happening now. For let j equals 0, I just gotta use another letter here, another value for my iterator, and then I have j is less than this dot storage I dot length, and then j plus plus. All right. Oop. All right. So for length is spelled wrong. yeah, so for each element within that, I'm checking the key value. So if key, so if this has storage I j, so you get the bin is at I, j is the first, or is the sub array within that array. And so here I'm looking for the 0, which is the key. And if you equal my key already, then we know that we need to set the value to the new value. I also want to say that I can break out of this because I don't need to, I already found my key, I don't need to continue looking for anything else. Minor inefficiency, whatever. Okay, so that's if the bin exists. If it doesn't exist, oh, okay, so I need a variable here to say if found. Okay, so let key found. Okay, so if the key is found, equals true. Okay, if the key is not found, key found. Oh man. If the key is not found, then we know that we can safely insert. If the key was found, we don't want to insert a new value because we just had to overwrite it, and it's already done. So here, now we can safely add to this .storage of the ith, and we want to append our key value pair. Okay, that seems complicated, but it all makes, it all flows, it all makes sense at this point. So I would like to have my hash table start with 5. ht.add, I want to add Bob, and I'm going to add a bunch of stuff. So I want to add Bob1, Bob2, and Bob3. Then I will console.log ht.storage, although you wouldn't normally do that. Let's check this out. Okay, we cannot read length of that. Okay, you can't read length of this .storage, but you should have set it here. It should be 0 though, undefined. So it's saying this is undefined. So if this .storage, oh sorry, I meant if not this. Yes, this is where key value not found, or bin empty. Bin is empty, therefore created. Create empty bin. Create empty array. Okay, so that should work. So this creates an empty array. I have my hash, I have my values, and everything's good. So at this point, the bin is created when it doesn't exist, it gets created. Then we set up our dummy variable here for checking if the key is found. We go through all this logic, break out when we are done and the key is found. Otherwise, nothing's happened. This variable hasn't changed and it's still false. Then we can safely append our key value to the array. So this should be okay, or not. Append is not a function, probably because that's freaking Python and this is push in JavaScript. Man, this is really gonna be throwing me off. Okay, cool. So I didn't push the value properly. Val. Oh, I see. That's my mistake here because I didn't provide a value for these keys. That's me. 42. Okay. This is gonna be Bob. Doesn't really matter what that stuff is. Okay, cool. So we see here that I started with 5 bins. So this first item is empty. Second item here, third item, hold on, this third item has 2 things. And the fourth item is this. So it's 1, 2, 3, 4. That doesn't quite make sense to me. I should have 5. It's because I didn't create them like I should have. So this should be a new array of length bin size. And it's like an empty thing, okay? So here we go. Yeah, so I was adding... I was like creating the array. I was like expanding the array based on what I was adding to it, but that is not quite proper. You should have the size already allocated like in memory. It should already be like partitioned effectively. So this is a little bit more proper, but it does work. It works exactly as you think it does. So that's good. So that's adding stuff. Let's do our CRUD and talk about. So it's not just CRUD. It's actually updating as well. So add is technically updating too, right? I think I could just do like update key val and call this dot add key val, because it effectively does the same thing, because this part here is the update. If it exists, it does update. And update effectively adds anyway, so yeah, I think this is fine. This is a fine implementation. And delete, right? Delete or remove. Maybe I should call it remove. I like delete. It sounds so final. You care about just deleting the key. So once you find the key, you are out of there. And here is where our indices comes in. So we have our const I equals. Is it const? It should be const, yeah. We take the key, we hash it. Okay. And then we can grab our... So now we need to do a search. So this key needs to exist. So if bin exists, so it's sort of this similar situation here. So I'm just going to store that. Okay. First I need to check to see if this dot storage I. Okay, so if not, then this key doesn't exist. Throw error, key not found. Okay, so that's one situation to think about. Like this key, whatever key gets brought in, it may not even be part of the data structure. So you have to keep that in mind. And it's the same thing here. So key found, if bin exists, check if the key already exists. If so, delete. Delete it. Alright, so you go through the storage at I, and if you find the key, then we're not overwriting anything, we're actually just straight up deleting it. So this, I think, is just del. Am I right on that? Unexpected. What? No. Storage here. Where is it? Where am I thinking del from? Is that Python? Holy crap! Python del. Del is a keyword in Python. Of course it is. I'm messing it up again. So if the key is not found, then here I also will throw the error that hey, this is not what's going. This is not okay. All right, cool. Let us do ht.delete. I'm also going to do these as update because I can do that. And we will delete Bob2. All right, cool. Let's see what that looks like. All right, bam. Okay. Error. Throw. Key not found. Key not found because Bob2 is a key that should be in there. 52 it says. So key not found here because I did not set it here. Okay, I needed to not delete that. That information was important. Well, when you spell things properly. Oh my goodness, true. I swear I've programmed before. I swear. This is not my first time. Okay, cool. So Bob2. So it looks like it deleted it here. Is that okay? Splice. Dot splice. Give me information. Technology. Come on. Is it like that? No. How do I get your information? So I need to do splice from I. I'm splicing J1. Yes. Let's try it again. Booyah. Oh. Is there anything else I need to put in here? I add, I delete, even update, and I think let me see that I took care of collisions, so I think that is the full implementation in a kind of roundabout way. I know it's not the most efficient for sure, having to use like another data structure. Also, there are ways of doing it with like a linked list. Instead of storing it in an array of arrays, you can actually have just this be a linked list, and you just add on to the next. You just add your new value onto the next one, and that's all you have to do. So, of course, I can implement that as well, but I'm kind of being lazy right now and just really getting an understanding of how hash tables work, period. So I think that was a pretty good example. One thing I didn't mention was the big O notation. So what's very cool about the hash table is that it has very, very quick lookup. So no matter how big the table is, because you hash the key value, you can really quickly search and index on even a large amount of data very, very quickly. So it's practically like O of 1, basically. A little more than that, but it's not like much. It's not significant enough to even talk about. And the space complexity is it takes as many elements as it is given. So I mean, I don't think you can get more efficient than that anyway. So anyway, that's it for now. Hope that was useful and enjoyable, and I will see you next time.